All right. We are in geometry lesson 6-8. We are starting to graph circles. And there it is. Sure. Today's date is Friday the 13th. Oh man, it's March 13th. Dun dun dun. Gunnar, what is our objective today?
Graph circles from equations of the form x minus h squared plus y minus k squared is equal to r squared.
Yeah, so our entire next few, next 2 or 3 lessons are all based on can you graph a circle? And I'm hoping that some of you are feeling uneasy. You're like, no, that doesn't work. Because in Algebra 1, I taught you, in not so many words, the vertical line test. This passes the vertical line test. It is a function because if I draw a vertical line on this, it only touches the function once. Therefore, it is a function. I'm going to be showing you guys a circle which does not pass the vertical line test. It is not a function. What's going on here? Well, that is a circle with a line.
That's a circular line.
So let's go ahead and start playing with this. Everyone, laptops open, follow along. I give it to you in the notes as well, what we're about to be doing. We're going to desmos.com/calculator. If I click on that, you should have a graphing calculator. We are not using the scientific calculator. You should be seeing something that looks like this. And let me change the settings so I'm in projector mode also, so you can see what's happening. So desmos.com/calculator, or if you click on Desmos, click on the big red button that says Start Graphing. All right, so and when you get here, you need to start typing this in. It's in your notes, x minus h squared plus y minus k squared is equal to r squared. And it should look like this. You need your parentheses, x minus h quantity squared plus y minus k quantity squared equals r quantity squared. And then once you have everything typed in, can I zoom in here? I can. If you have everything typed in correctly, it should say, hey, do you want to add a slider for h, k, and r? And you are going to click on all. If you click on all, you'll be able to have sliders, and then you can start playing around with this. What happens if you drag certain sliders? You should be able to discover that. And that's what we're doing. The first question that I'm asking is, what do you notice when you move h and k, and what do you notice when you move r? So as you're playing with these sliders, write down your observations you're going to be sharing with a partner and then with the class. Again, I will repeat the instructions again because I know that not everyone was at that point. We are typing in this formula. Once you get here, you're going to click on the all button and it will create sliders. So if you click on all, you have sliders. And the question that I'm asking for the first question is, what do you notice when you move h and k? When I move h and when I move k, what's happening to your graph? And you're going to be like, when I move h to the right, or when h gets more positive, it does blink. When k is more negative, it does blink. Write down your observations. What happens when you move r? When r, the sliders move, what's going to happen? What's going to happen to your circle? Write down your observations. I'll give you guys another 2 minutes. All right, so someone share. What did you notice when you moved h and k? What specifically? Julian, Card, thank you.
R makes it bigger.
R makes it bigger. So if I say if R was 1 and I make it half, then R is going to get bigger?
It makes it bigger and smaller.
Oh, it makes it bigger and smaller depending on what?
The positive or negative.
Okay, so if I have negative 10, is that going to be bigger or smaller than 2? Okay, let's try it, right? So if I come over here,
I don't know.
so if I make it negative 10 is there, and then 2 is right about there. Why is negative 10 bigger than 2? Say again? Okay, so there's a cool trick that you guys can use. If you click on the 10, you can actually say step by 1 and hit enter, and then it jumps by integer numbers too.
Whoa.
Pro tip. Step by 1, and I can change the bounds here as well. For example, my radius, what if I want my radius to only be bigger than 0? I can type in 0 and hit enter. Now I can't drag it to a negative number. I can't get over there. I can only get it up to 10. If I want to make it 1,000, and then I'll have to zoom out on my graph a little bit, I can make this circle go really, really big.
Whoa.
Yeah, so it is kind of fun to play around with this. I'm going to go back to 10 though because that's too big. I'll give you guys another 30 seconds because it is kind of fun to play with.
circle's so big I can't.
But yes, R does affect the size of the circle. I'm going to write that down, Julian. Thank you. You said the size, right?
There it is. There's a circle. I found it.
Change, and I think I'm going to type this. It'll be faster for me to do for my notes. Changes the size of the circle. Anything else that people notice? For R, H, K, anything? Quiet raised hands. Get some cards in. Need some cards. Need some cards. It's easy. Like, you say something, it could be wrong, but you still get your card in. What'd you notice? Something mathematical. Some pattern that you found. Do you have your card, Andres?
Magical.
Yes, sir.
What did you notice, Andres?
I noticed that the circle never touches a vertex.
What do you mean by that?
Like when you graph it, it just touches the sides, not the vertices.
What do you mean by the word vertice, I suppose?
It's like, for example, this.
Oh, it never touches those lattice points?
Yeah, that's.
Okay, yeah, so it could have touched those lattice points
Look.
if you're very, very careful.
Play them, or just play it. Press the play button on the left for both of them.
So it does, it just is...
But on mine it doesn't.
That halo.
I think that's because yours is just off by a pattern.
Okay.
Because I can make mine touch a lattice point right there.
Is that, did you hack or something?
See, look at that last point at, what is that, 12, negative
Mr. Sandusky.
18. Interesting. Sergio, what did you notice?
So since K is attached to like Y,
Yeah.
that's why it's like moved down and up. You like move K.
Okay, so there's two things that you said that I really want to make sure that everyone understands. So first, you said that K moves it up or down, and H moves it left/right. But you also said something really cool as well, that it's attached to the Y and it's attached to the X. So if H is attached to the X, it will move it in the X direction, left and right. If K is attached to the Y, it will move it in the Y direction, up and down. And yeah, that's a really good pattern notes.
You're right, Mr. Sandusky.
So one thing I noticed that no one has said so far is, why are these minus signs? Shouldn't I just have plus, 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 plus? Why are we doing a minus sign?
No, never.
The reason that I'm doing that is because they're opposites.
Wow, I didn't know that.
So check this out. Some people would type in the equation x plus h and y plus k, but now check it out. If I make h go left, the circle goes right. So if h gets smaller, the x value gets bigger. If k gets bigger, the y value gets smaller. They're opposites of each other. So remember this. If you don't take anything else away, well, there's a lot of things to take away in terms of what moves what. But remember that the thing attached to y isn't going to just move up by, so if k is 8, if this is an 8 right here, that means I'm going down 8. They're always opposites. They're inside the parentheses. And that's kind of a theme that you'll see throughout all of Algebra 1, Geometry, Algebra 2, etc. If you have a number that's inside the set of parentheses, the opposite happens in terms of its graphical representation. And I'm going to put over here, in all caps, opposite.
Yeah.
I will say opposite of the number you think it will move. Or opposite of the direction, I should say.
Will this be on your YouTube channel?
It will be. Yep. Hello, YouTube.
Mushy, mushy.
All right. So, let's go ahead and talk. Oh, yeah, Sergio.
Another one is R equals the radius. That would like the 10 equals 20.
You are indeed correct. So we can see that easier if I make k and h both be 0. And then zoom into my graph here. So if I make r is equal to 2, oh, it intersects at 2. The radius between 0 and 2 is 2. If I make r 1, the radius is now, you can see right here, 1. If I zoom out a little bit and I come out to 3, if I make r is equal to 3, the radius is 3. R is the radius. So I can come down here and say R is the exact size of the radius of the, I can't spell, radius of the circle.
You can't. I don't believe that you can.
That's true. I have a fixed mindset when it comes to spelling, don't I? It's okay. I made a mistake, but I got smarter. Modeling. There it goes. All right. So I'll say kind of the same things that you guys already analyzed in this down here. This was kind of the catch to make sure that we got everything. H, this is going to be the opposite. So first of all, it's going to move left or right. But the main thing is it's going to be an opposite. K is going to move it up or down. And it's the opposite of whatever you think it is. If it's a negative, I'm going up. If it's a positive, I'm going down. So again, it's an opposite. And R, I have to be careful about. In order to get just R by itself, well, I have an R squared now. So if I want to get R just by itself, I need to take the square root. So I'll say take square root to find R. What do I mean by that last one? Really quickly here. I'll let you guys copy this down. Once I see pencils stop writing, I want to explain this a little bit more in depth. And what time do we get out of here? 9:17. I got time.
Mr. Shino, what's after time? What's after radius?
What's after radius?
Where you type it, yeah, radius of radius of.
All right. So if I come back here and I get rid of, actually, I'm going to hide this. So I'm going to hide this and I'm going to type in an equation. I'm going to say x squared, which is really x minus 0 squared. I'm going to say plus y squared is equal to 36. How big is the radius in this case?
Pretty big.
How big is the radius? Well, I have the center as 0 and I count out 2, 4, 6. Wait, the radius is 6? How did I get 6? I took the square root of 36. What if I change this number to 25? Now the radius is, you guys will all shout out.
Only one?
4.5.
Come on, guys.
5.
5. You take the square root. What if I had that equal to 4? Then the radius is 2. You always take the square root of whatever this number is, and you will find the actual radius, because that number had to be squared for our formula. All right, so if I have this formula and it asks, what is the center? The center is always the opposite of whatever negative h is. What is the opposite of negative h? Quiet raised hand. What does an opposite mean again? Quiet raised hand. What is opposite of negative h? Fernando? Positive h. And therefore the opposite of negative k is positive k. And I did the x coordinate, which is h, because x is attached to the h, and then the y coordinate k, because k is attached to the y. So that will always be the center of the circle. Whatever h and k are, the opposites of those. Oh no, okay, don't know what I'm doing here. H comma k is always the center of your circle. And then the radius is always going to just be r, which means you have to square root it. So be wary. It's not whatever is on the right-hand side that is incorrect. Whatever's on the right-hand side needs to be square rooted in order to find the radius. I think I've kicked that dead horse enough. Andres can't see your ears. Example number 1. Okay, so this is a type of problem that you might encounter in Khan Academy. Khan Academy, cannot pronounce my words. X plus 3 squared plus y minus 22.7 squared is equal to 9/16. Okay, what's its center? Quiet your hand. 2 people know. Who has their card? You don't have your card.
No.
Who has their card? Eder, yes. I'll help you out, Eder. This is the x coordinate, and I take the opposite.
The opposite of 3.
Opposite of 3. It's not positive 3, it's negative 3. Comma, you're halfway there. And then the y coordinate, well, this number's attached to the y coordinate. What's the opposite, Eder, of negative 2.7?
Positive.
There it is, positive.
I give
2.7. All right, Eder has the center down. Okay, now I need to find its radius. How am I going to do that? Someone has a card. I told you like 4 times. What are you supposed to do with this number on the right? You do some operation to it. Look at your notes. Look up above. No, give me Eder's card.
I got it.
No one has a card.
I'll get it.
All right, cold call. Looks like it's Jenny. What do I do with this number on the right, Jenny, in order to get the radius? Look up at your notes. I said something up here. Take the square root. Everyone write it down. We are taking the square root of 9/16. How do I do that now? Does anyone remember how to do that, Sergio?
Can you simplify?
Yeah, how do you simplify?
Like divide by 3. Like,
Divide the top and bottom by 3. Well, 16 isn't divisible by 3. 15 is divisible by 3. All right, I'll give you a hint, a reminder. This is going to be the square root of 9 divided by the square root of 16. And now I'm going to either cold call or hopefully get a quiet raised hand with a card in it that belongs to that person. How do I simplify this? No one? No one? No one with a card? No one with a card? I need all of you guys to participate. I need to hear from all of us. All right, Cohen, go for it. Square root of 9. Square root of 16. Careful. Done. Cohen has told us that the radius is 3/4. And if I need it as a decimal, I can say that is equal to 0.75. Either way is fine. Both of these are okay on Khan Academy.
Are they enough?
All right, let's try another one. I'm going backwards now. You have 2 assignments. This is like assignment number 1. What's the center? What's its radius? Same thing over and over again. This is the second assignment. You need to make your own graph. You are going to graph a circle. So first, in order to graph your circle, you're going to need to find their center, and you're going to need to find your radius. Exactly what I had you do up here. Let's find its center. Everyone write down, what is its center? You're going to be doing these same steps when you're doing the homework. What is the center? Someone, quiet raised hand. What's the x coordinate of the center? What's the y coordinate of the center?
5 feet. Or actually, not 25.
Is there a
but
quiet raised hand? I'm going to have to cold call on someone, it looks like. Who's it going to be? Monse? Yeah. Ooh, good guess. So this one is a trick question. If I have x plus something to equal x, this something must be 0. X plus 0 is x. So therefore, this is really x plus 0, and therefore the center x coordinate is 0.
Negative 0.
Haha, funny. Negative 0 and positive 0 are the same number, just for the record. And then what is the y coordinate of the center, Monse? 2. All right, Monse has the center for us. Thank you, Monse. I now need to find its radius. Who can find the radius? Someone that has their card. Who's it going to be? There's only a few people that have their card. Josie? Yep, so I'm going to do what with 49? And you get? 7. Done. Thank you, Josie. I think everyone's in now, right? Okay, now I can call multiple people over and over again. Let's graph this. Oh, did I forget someone? Jenny, did I forget you? No. Cohen, did I forget you?
didn't forget that.
I think oh, Julian, did I get you?
Yeah, you got it. You got it.
Okay.
You get going.
Let's graph 0, 2. Everyone graph it right now. Graph 0, 2. 0, comma 2. Graph 0, comma 2, everyone. I'm going to graph 2 points. One of them is wrong. Which one of these is 0, comma 2? Is 1 or 2? 0, comma 2. All right, I guess I should label it with letters so I don't start having too many numbers in here. Which one is 0, comma 2? Hold up. A or B? Is it A or B? Everyone vote now. 1 or 2? A is 1, B is 2. What is 0, comma 2? Come on, vote real. 3 is not answered. Okay, good. Most people are saying 1. It is 1. It's A.
No, it's 3.
All right, so 0, comma 2, that is its center. Label it. That's the center. Done. Okay, then I'm going to count out 7. 7 is the radius. The radius can go to the left. It can go to the right. It can go up. It can go down. All of those. Let's do all 4 of them. So I'm going to go up 7 from the center. I'm going to count up 1, 2, 3, 4, 5, 6, 7. Well, 2 plus 7 is 9. So I'm going to go up to 9. I'm going to go 2 minus 7. 2 minus 7 is negative 5. So I'm going to go down to negative 5. The distance between these points is 7. Okay, I'm going to go 7 to the right. If I was at the x-coordinate 0 and I add 7, I should be at 7. And I'm going to go 7 to the left. Come out here, 7. And I do my best attempt to make a circle. Haha, I have technology, guys. That's not a circle. Where's my circle tool? There it is. And that's not what I want to make. I want to make a blue, empty circle right there.
Right, right. Mr. Sindell's famous, or Mr. Sindell's famous, right?
On Khan Academy, you only need to drag one of these points and the center. There's only going to be 2 points that you use for Khan Academy. Again, I will say that twice. You only need these 2 points, or you could use these 2 points, or you could use these 2 points. You always have the center and a point that is on the circumference of the circle. That's all you do on Khan Academy.
That's pretty crazy to me.
All right. Go ahead and look at your left elbow partner and your right elbow partner. Whose circle is better?
Oh, bro. I think mine.
What kind of
Who's the best in this class at drawing circles?
Look at mine. Look at mine.
You have set the bar nice and low.
Nice and low.
Okay. Okay, let's see.
Tone.
Haven't
If
tried
Jose
yet.
was here, he would.
If Jose was here, he would have won.
Mine looks like a kite.
I think Fernando's in first place. So
Wow, you say
Yeah.
my circle was trash? I knew it. I
Fernando,
knew
hold
it was
your
terrible.
Mr. Sindell, did you congratulate Fernando?
I just did.
No,
Good job, Fernando.
This is his birthday.
Oh, happy birthday, Fernando.
Congratulations.
Congratulations on being born. All right, that's the end of the notes. Guys, give me a fist of 5. There are 2 parts to this. Can you find the center and radius of a circle with this type of an equation? And then secondly, can you graph that thing? Fist of 5, go, fast. Fist of 5. Andres, ears, come on. 4, 4, 4, 4, 1,
Oh, wait.
4, 4, 4, 4, 4, Josie, Julian, 4, 4, sorry, Julian. All right, those are some pretty good scores. I will give you guys this to end with. This is going to get harder
No.
by kind of a bit.
No.
We are going to need to complete a square twice in order to eventually solve these guys. So be warned, this is the baby step of graphing the circle.